Yes, definitely. As I told you, so ECE is future. So as you seen, the government is investing huge investments with respect to semiconductor, and huge investments are coming. I think it's a good choice for the students because ECE will prevail in future. Emerging technologies in the sense, particularly we talk with respect to the semiconductors. So then we are talking about IoT. So then we are talking about the embedded hardware.
When people think about placements, they only think about the industry opportunities. So what should an EC graduate think about when they think of passing out or the career option? If you could give EC one tagline, what would that be?
Connecting the future.
Hello everyone, I am Gaurav Sheshgiri, a student of BTech Robotics and AI, School of ECE, REVA University. And today I am joined by me by Dr. M Sudharshan sir, the Director of School of Electronics and Communication Engineering. And today in this particular interaction, we'll be discussing about the most commonly arise questions for the parents and the students who are the prospects of ECE as a field. And also we'll be discussing about the industry opportunities, the career paths, and many other things where the field is going to evolve in the next few years. Thank you so much, sir, for joining with me. And the first question that is commonly arised is, ECE as a whole is the backbone of modern technology. So how has this field evolved over the last few years, sir?
Before I take your questions, myself, I am Dr. Sudharshan. I am the Director for School of Electronics and Communication Engineering. So if your question is, ECE is the backbone. So yes, of course. See, if you take from the day where we had big systems which were all the vacuum tube based, and today you see all are under chip. If, for example, you take the radio, so the radio used to be that much big. So now you see radio is inside the pocket. So you have a FM radio inside your mobile. So coming to even the communication, you can just see how was the communication earlier, starting from the simplex communication to duplex communication till today, the wireless communication, mobile, 5G, everything. You see there is an evolvement. So there is definitely, you can see that in all these things, there is a hardware which we can call it as a backbone. So of course, this hardware should talk to the software. That is what is the, we can say that the electronics is the backbone for today's technology.
True, sir. Electronics has been evolving constantly, but few students are in a stereotypical mindset that electronics is all about circuits and hardwares. So how true is that, sir?
No, of course, electronics, if you see everywhere the circuits will be there. So, but that circuit is the one which is actually running the entire thing. The circuit should talk to your neighboring device, so there should be an interfacing. So circuit will be there. So but now circuits are also getting connected with the software. They are interfaced with the software, because ultimately only circuit will not work nowadays. So it is the circuit and the software. So both should talk.
So with the integration, in the recent times, AI, IoT, automation, all of these fields have started coming to the limelight, sir. So how is ECE as a field prepared for that particular aspect?
Okay, see, ECE, see, again, if you take into artificial intelligence or machine learning, all these things, if you look into, see, we were learning earlier for ourselves. Now machines are learning for ours. If you look into, so earlier we used to do any sort of the regular job. So now machines are ready for doing. That's what is this artificial intelligence and machine learning we are talking. So definitely, if you consider the machine learning, so that is again embedded into a chip. So your chips are becoming more and more intelligent. For example, if you take your mobiles only, so earlier your mobile was just used for a basic communication. So now your mobile is embedded with an intelligent thing. So you are embedding it with GPT, all those things, so that your mobile is getting adopted. That means your AI is also coming to the hardware.
And what are the emerging technologies in this particular field, sir? ECE as a subset has IoT, it has all the other fields. So what are the emerging technologies under ECE that ECE students must be focused on?
Emerging technologies in the sense, particularly we talk with respect to the semiconductors. So then we are talking about IoT. So then we are talking about the embedded hardware. See, these are all the embedded things which are coming into as a emerging technology. Maybe I'll just take one example. Maybe we will talk semiconductor. Many people nowadays, since even government of India is also talking more about semiconductor investments, all those things. I'll just take one example. See, we talk, hey, one chip has got 4 millions of transistors. But have you ever thought that how 4 million transistors are placed in that small chip? Or how that 4 million transistors you will verify that it is connected properly? So that's what is these technologies which supports the engineers. See, these are all the things which is the new thing. So that's what we call it as a verification. It is almost analogous to the testing engineers which are there in the software. So nowadays you can see there is a huge boom. I think just 5-6 years before also, huge people were shifting towards the software testing. See, this is hardware testing. See, 4 million transistors, literally it is humanly impossible, but there are technologies which are available like DFT, design for testability. So there is a huge requirement for the hardcore VLSI engineers or electronics engineers. So that will verify. So this is possible through a language called System Verilog. That is what we learn in School of ECE. So System Verilog and Verilog VHDL. So these are all the things which will support for the testability, particularly with respect to hardware testing. So future ready engineers has to integrate circuits, software and the AI. So definitely, so there is a good future for these things.
So as you told, sir, there is a lot of integration that's happening and there are a lot of opportunities in semiconductor field. But how should ECE students approach this particular opportunity in a semiconductor field? How should they look at the opportunities for semiconductors especially?
Okay. See, semiconductors is not like, it's a vast field. So we are just telling semiconductor. But if you look into semiconductor only, so there is one field that is, we call it as the VLSI. So we will tell very large scale integration. So in that we have specifically digital and analog. So digital is one vast field again. So because there are huge number of openings are there. Analog is another one. So where if for example you take say the design of an ADC or a design of a PLL. See, these things comes under analog design. It is, I know the jobs are limited, but the engineers are hugely paid. But on the contrary, if you go to digital VLSI, so as I told about previously, I was talking about the hardware testing. So that is particularly with respect to the design for testability, all hardware engineers, those things and all. So these are all the field where the electronics students can harvest the good jobs. And for a specifically with respect to the freshers, those who go out of the university, so they can work towards physical design. So physical design is what is, we call it as the layout. So huge number of layout engineers is required for all the industry. For example, you take any semiconductor industry starting from the NXP, NVIDIA, so then microchip, so then coming to the global foundries. So everywhere there is a requirement for the physical design engineers.
True. So since we've anyhow spoken about the physical components of electronics, let's visit our circuits lab and then continue the next few questions.
Sure.
So as you can see, I'm surrounded by all these interesting lab components. We have a radar trainer, we have antennas, we have a whole CRO and radar setup here. So sir, what impact does this get to the EC field, sir?
You have rightly identified, Gaurav. This entire setup is the radar trainer setup, what has been taken from our lab. And see, understanding radar is not easy. So to make the students to understand in a better way, so we have taken this radar trainer kit and it will be useful so they can literally understand. So whenever there is a obstacle, so it will give the message or it will give how long the distance the obstacle is there. So this will definitely make the students to understand it in a better way, the radar principles and all. Because nowadays you may see these radars are now coming everywhere. Don't think that it's there only in the war field. So radars are there in your autonomous cars today. So you see any equipments, particularly when we talk about autonomous world we are talking. So I think understanding radar is equally important.
And how much of an impact has the coding done to electronics, sir?
I think coding is something like we cannot live. It's there were earlier days that people were thinking, I am an EC guy, I will not do coding. No, it's not that way. So even though you are an EC guy, so coding is equally important. But let us understand that coding should complement the electronics. It is not something which we are replacing. So for example, any particular hardware you take, ultimately it should talk to some other hardware. So if there is some hardware it has to talk, means it has to have a coding.
It's very key for communication.
Yes, definitely. So coding is, as an electronic students, they will talk about assembly language. So in addition to that, they should also learn C, C++, then Python, and of course DSA is also required. So coding is something which you cannot say that I will leave and learn only circuits. No, you have to learn both the codings, because hardware and software should work together. It is always coexisting. So to facilitate this, we have taken coding since from the first semester. So programming in C. So then we will take the students to programming C++, then DSA. Then we will take them to Python and Java. So all these things are taken level by level, so semester by semester. So we will be taking. So this is one thing what definitely addresses the coding issues of the students. Out of my experience also, particularly when we used to interact with the placements, so they used to tell EC students are dull in coding. These were the days. So now that is being taken over by adding these coding things in all our curriculum.
And sir, when you particularly speak about software and hardware, EC in particular has subsets right now, sub-branches. What has EC in particular, School of EC, taken as measures to implement these new technologies, sir? Do we have any other branches? How are we going about with this technical change?
In School of ECE, we have one program, that is BTech in Electronics and Communication Engineering. So we have a diversified programs like Electronics and Computer Engineering and Robotics and AI. So these two are the programs which are diversified. So if, for example, if you take Electronics and Computer Engineering, it's not that 50% of electronics and 50% of computer, not that way we can tell. So it's a good mix of hardware and software. So students of electronics and computer are now studying the coding things, and in addition to that, they will get the complete focus of the hardware also. In that way, I can say they are at one step closer or slightly above compared to the CS graduates. Coming to robotics and AI, so now you can see that the entire world is changing. So we talk about autonomous car, autonomous robots. So then we talk the humanoids. So you can see even everywhere we see that it's going to take its place. So in School of Electronics and Communication Engineering, we have a BTech Robotics and AI, and we have the very good curriculum which is going to cater to the needs of the BTech Robotics and AI also.
So this was pertaining to the education part. How about internships, sir? What support are we offering to the intern graduates? And what about the internship support in general for our students?
Industry doesn't want a fresher to come and sit in the workbench for at least some duration. So industry wants people who are ready to be deployable on the project from day one. That is what industry is saying now. They don't want to see again another 6 months or 1 year for training the students. So to facilitate this, we are sending the students for the internships. So in internships, what is happening is we will be sending the students for a complete 7th semester and 8th semester for the internship, where the students will be trained in the industries and they will be given an opportunity to work hand in hand with the engineers, and they will be getting the stipend also. So to facilitate this, what School of ACE at REVA University is done is, so we have taken the credit transfer of 2 courses to internship. if a student is doing an internship in an industry, so he will be given a credit transfer of 2 courses, so that equivalent to 6 credits we will be taking that in terms of the internship. So that I have seen good number of students doing internship, and I am happy that students have reached internship stipend up to 1.2 lakhs per month.
And sir, when it comes to internships, it's more about corporate life. What about people who genuinely want to start up something? What about people who want to become entrepreneurs? Do you think ECE branch in a whole can support entrepreneurship and startups as well?
So it's a very good question, and I was going through a survey, a recent survey, and through that survey I came to know that nowadays the students are not that much interested to go for a 9-to-5 jobs. Maybe it's a survey report, but still we have seen that is true, because the students are creative. So some students are really creative, so they don't want to go for a 9-to-5 jobs. They want to do their own startups, or maybe their own entrepreneur thinking mindset it is there. So to accommodate such students, so REVA University has a very good ecosystem called REVA Nest, where students are given an opportunity to do the incubation, so much before they get incubated. That's we call it as a pre-incubation. So they will be taken under pre-incubation, then incubation, then to the startup, and they will be entrepreneurs. So out of my experience, so earlier if I could see out of the entire branch, 1 student also we were not able to see as entrepreneurs. Now we will see more than 30-40 students going for pre-incubations and having that entrepreneurial mindset. So that ecosystem is there with us.
Also, the main highlight of REVA University has been educate to enterprise. So all these extra courses apart from just EC, what is EC also taking up, sir? Because often people think it's only about labs, it's only about curriculums. Apart from this, what has EC taken, sir, the initiative?
So maybe I can talk with respect to bringing the entrepreneurial mindset. So we have taken the innovation and entrepreneurship. So that is even taught by our university people and the people who are already entrepreneurs. So other thing is bringing the engineering mindset. So we have taken design thinking. So then one more thing is engineers should know economics also. So students are an engineer, they cannot say I don't know the economics pattern. So to inculcate that, so the courses like finance and accounting is a 1 credit course which has been introduced across all the branches. So it's not only for EC, across all the branches. So that is giving the students that the way they should think as an entrepreneurs and the economic point of view also.
And how about placements, sir? When people think about placements, they only think about the industry opportunities. So what is the industrial career path for ECE graduates, sir? Where can they exactly land up? Is it the software field? Is it the hardware field? Or is it a mix of both? So what should an ECE graduate think about when they think of passing out or the career option?
Of course, ECE graduates are able to get good opportunities in hardware jobs. So hardware in the sense, as I was talking, so all these semiconductors, then automotive electronics, so then robotics, so then electrical, so all the things they can be fit in. But at the same time, students of ECE has an opportunity to work in IT also, because as I was talking over to you, so we are equally making them to get ready with the coding also, so they can definitely get absorbed in IT jobs also. That's what I have seen. So the students of electronics have got placed in IT as well as the core industries also. So and recent years I have seen the number of students getting into the core industries also increased. So earlier core industries means the number of students who are going used to be comparatively lesser. So nowadays that trend is changing. So students are taking a pause before they select an IT. So they are taking, yes, there is an opportunity for me to go to hardware, so let me choose hardware industry. So one thing is particularly with respect to the core jobs, the initial salaries may not be fancy. But definitely when once they get in and they will get experience, so definitely the salaries will increase exponentially. That is true with any hardware and core jobs.
And what about the current timeline, sir? 2026 to maybe 2030. How do you think this time will benefit the EC people, sir?
So it's an era of semiconductors and AI. So definitely the core EC people will flourish.
So also as a whole, what about EC, sir? Do you think people are going to be choosing this branch?
Yes, definitely. As I told you, so EC is future. So as you seen, the government is investing huge investments with respect to semiconductor, and huge investments are coming in AI. So you can see that the NVIDIA, all those things, so many government opportunities, governments are creating the funds for such opportunities. I think it's a good choice for the students because ECE will prevail in future.
So with the growing trends of AI and automation and semiconductor, do you think it's the right time for people to choose ECE as a field, sir?
Definitely. So looking into the support the government of India is giving for the semiconductor industries and setting up of the semiconductor fabs, and looking into the jobs that can be created by 2035. So there is a survey which is telling that by 2035, 20 lakh plus jobs will be created.
For engineering? ECE.
Yes, in ECE.
Oh.
So this is a huge opportunity for the core ECE students.
Also, sir, could you please explain us as to how the industrial collaborations are being taken seriously, that the students are getting exposed to new technologies of the current generation, sir?
See, coming to the industry collaborations, I have already told you about the NXP, so then Spark Minda, so then I have also talked about Centum Electronics. In addition, some courses we are taking the support from the industry to teach. For example, we have a course, Data Communication and 5G Networks. So that particular course is being co-mentored by Wipro, and our faculty has been trained in Wipro Chennai campus for a duration of 10 days, and the same faculty is taking the course in REVA. So that has helped our students to get a better insight into the course rather than our own faculty teaching. Now it is co-mentored with the industry. And also coming to one more course, so QNX technology. So QNX, it's basically it's an operating system which works for the automotive domain, which is used for safety and driving, all those things. So through the program of QNX everywhere, so we have developed a course which is mentored by QNX and Pi Square Technologies. That course is real-time operating system using QNX. It's just like how you have an operating system, you have a Windows operating system, you have a Linux operating system. So like that, QNX is an operating system for automotive. So it takes care of the driving, safety and all other things. So nowadays we talk about these things with respect to automotive. So this can be also called as a software driven approach. So the vehicles are no more called as the vehicles, we will be calling it as a software driven vehicles, SDVs we call.
Also deployment of airbags immediately.
Yes, so the safety concerns, all those will taken care.
So it's wonderful as to how software and hardware is going hand in hand, and how EC is taking the collaborations and placements and internships so nicely, sir. I hope we've answered and clarified as to all the queries that the parents and students have who are the prospects of EC as a particular field. Before we end the entire conversation, I think we'll have to go through a small rapid fire. So we'll be having a set of 6 to 7 questions, and post that we'll be letting the students make their choices along with the parents. So sir, now we'll be beginning with the rapid fire round. So the first question that comes to our mind is one technology that will be evolved in the next decade.
Semiconductors and AI.
And one myth that you want to break about EC.
Only about circuits.
And software or hardware, what excites students the most?
Software first and hardware next.
If you could give EC one tagline, what would that be?
Connecting the future.
One skill that every EC graduate must develop before graduation.
Problem solving skill.
And one advice, one final advice to those students who are confused between EC and CSE.
Follow your interest, not the trend.
So after all the conversations that we had, how would you like to conclude the entire summary of what we had, sir?
Conclusion is quite difficult, but however I'll try to concise. See, AI cannot work without processors and chips. IoT cannot work without sensors and communication. Then coming to the automotive, which cannot run without embedded systems and the control engineering. I think future is electronics and communication everywhere.
I truly, sir, I feel the future is electronics and communication too. And with this, we come to an end of such an insightful session that we had. I'd like to once again thank you so much for taking your time off and addressing these important questions and to give us a clearer idea about the future of electronics and communication. And I'm definitely hoping that all the prospective students have a lot more clearer vision and idea about the future, the opportunities, the skills required, and everything pertaining to this particular branch, which is the field of electronics and communication. Thank you so much, sir, for being here, and thank you all for watching this.
Thank you.